Hi there. This is Espin Dolores. I would be delighted to help you with upcoming presentation. If there's anything you need assistance with, please don't hesitate to reach out to us at info@espincorp.com or visit our website. Providing exceptional service to you is our highest priority. We sincerely hope you found it valuable and informative in some way. If so, we kindly request you to like and share it with someone who might also benefit from it. The significance of reverse engineering in the modern world, from software security to national cybersecurity. The concept of reverse engineering is widely discussed and often asked about. Reverse engineering refers to the process of disassembling and thoroughly examining a product or device in order to understand its manufacturing concepts, typically with the goal of producing something similar. In the field of mechanical engineering, reverse engineering summarizes the process of reconstructing an existing object. When creating an object from scratch, an engineer would typically start with a design specification and produce drawings to guide the construction process. In software engineering, reverse engineering is conducted to retrieve the source code of a program when it is lost, to study how the program performs specific operations, improve program performance, fix bugs when the source code is unavailable, identify malicious content such as viruses, or adapt a program for use with a different microprocessor. However, it's important to note that copying or duplicating programs through reverse engineering may violate copyright laws, and certain software licenses explicitly prohibit reverse engineering. Reverse engineering can be seen as a process that involves analyzing a system to identify its components and their relationships, creating representations of the system in another form or at a higher level of abstraction, and ultimately creating a physical representation of the system. The process typically begins by obtaining dimensional information through 3D scanning, whether it's for mechanical components, consumer products, or ancient artifacts. Reverse engineering finds application in various fields such as software engineering, entertainment, automotive, consumer products, microchips, chemicals, electronics, and mechanical design. For example, when a new machine is introduced to the market, competing manufacturers may disassemble it to understand its construction and functionality. A chemical company might employ reverse engineering to circumvent a competitor's patent on a manufacturing process. In civil engineering, past successful bridge and building designs are often replicated to minimize the risk of catastrophic failures. In software engineering, good source code often builds upon existing good source code. Reverse engineering serves multiple purposes, including as a learning tool, a means to create compatible and cost-effective products, enhancing interoperability between software systems or databases, and uncovering undocumented features of commercial products. It can be viewed as a process that starts with the product and works backward through the design process to arrive at a product definition statement. This approach helps reveal valuable information about the design concepts employed in creating a particular product. While artificial intelligence (AI) has made significant progress and enabled the creation of comprehensive programs from scratch with complete source code, reducing the need for reverse engineering in certain areas, it still holds a crucial role in specific domains. In contexts such as malware analysis and government inspections of software programs, especially in terms of national cybersecurity, reverse engineering remains indispensable. The emergence of AI has revolutionized the software development process by allowing programmers to generate code automatically. This approach has greatly diminished the reliance on reverse engineering, as developers can swiftly and efficiently construct complex programs without relying on existing source code. However, reverse engineering continues to be relevant in certain areas. One prominent example is malware analysis, where reverse engineering plays a vital role in studying and understanding malicious software. By dissecting malware code, experts can identify its functionality, vulnerabilities, and potential countermeasures. Reverse engineering empowers cybersecurity professionals to effectively detect and neutralize these threats, protecting individuals, organizations, and even nations from the detrimental effects of cyber attacks. Furthermore, reverse engineering holds significant importance in governmental settings, particularly when procuring software programs critical to national security. Government agencies often conduct thorough inspections of software products before acquisition to ensure they meet rigorous security standards. By utilizing reverse engineering techniques, experts can meticulously examine the underlying code of these programs, uncovering potential vulnerabilities, hidden functionalities, or undisclosed backdoors that may pose risks to national cybersecurity. The ability to reverse engineer software programs enables governments to ascertain the trustworthiness and integrity of the software they acquire. This practice ensures that the procured software is free from any unexpected surprises or components that could compromise national security. Through meticulous inspections, governments can confidently deploy these software solutions, knowing that they have undergone thorough vetting and meet the highest cybersecurity standards. In conclusion, although advancements in AI-driven approaches have reduced the need for reverse engineering in certain areas, the practice remains relevant in various domains. Malware analysis and government inspections of software programs continue to rely on reverse engineering techniques. By leveraging these methods, cybersecurity professionals and government agencies can strengthen national security, proactively address potential threats, and make informed decisions when acquiring software solutions. Reverse engineering serves as a valuable tool in safeguarding against cyber threats and ensuring the integrity of critical systems.